Now, I want you to notice on my slides that I have the ICA and the Heartland group, but you must understand I do not represent these groups. I'm speaking on my own. I have these symbols as a courtesy to the people who are organizing. But if you want to throw snowballs, you have to throw them at me, all right? I'm also going to be talking about the flaw in some of the sea level rise projections that are currently done by satellite. There are two different measures, satellites, tide gauges. They are different. I'm going to explain why they are different, how they are different, and how they can be reconciled. I'm going to talk about some strange things, strange predictions, and you're going to see two of them right here. You see the current IPCC projection says we're going to have 1 meter of sea level rise by 2100. The current American National Climate Assessment says, okay, we're going to have 8 feet, which is almost 2 meters, okay? And how is this figured? They are using what is called representative concentration pathways. This is an invention of the IPCC, and it is calculated on the amount of CO2 that humans produce and the amount that we are able to reduce, okay? And you see these 3 paths, and they're crazier here. I mean, this is absolutely ludicrous, and you'll see why in a few minutes. But again, the lowest figures that they show here and here are based on almost no emissions whatsoever. That means you're going to have to close all the factories, stop all the cars, figure out how to launch spacecraft with wind and electric. I need help on that because I work with my friends at NASA, and we have to send these things in the air. And also, how do you fly airplanes that way too? Okay, let me see if I can get these slides to move properly. This is the latest National Climate Assessment in the United States, not quite the 2018, but 2014. And again, you see 6.6 feet, which is even higher than the IPCC. They're trying to, it's 2 meters basically, instead of 1 meter. They're trying to outdo the IPCC. And again, the bottom one is terrible draconian reductions in use of CO2. Now, the states in the United States copied these projections into their own projections. And so here's one of them that I was involved with. This is the New Hampshire Coastal Risks and Hazards Commission. And I happen to have been on that commission, fighting against these things, but I lost, okay? And again, you see, it starts in 1992 and goes up here, and depending on how much CO2 is there. And that arrow is the reality. We are not even halfway to the total elimination of CO2. And sea levels haven't gotten there. And here's an enlargement. You see how that's a very precise enlargement as to what the actual sea level is. And the fact is, we are still producing CO2 at the regular. We haven't abated it at all. So there should be one more here. There we go. This is the most recent National Climate Assessment. And how are sea levels going to rise even more? And this, again, our actual is below what you see as the lowest figure. So, is CO2 a major driver of the world's coastal sea level rise? It certainly drives the IPCC's models. Does it play any role at all? I think you're going to find the answer maybe not surprising considering what I'm talking about. So here are some claims beyond belief. Okay, Gordon and MacDonald in 1979 predicting where sea level will be in 2020. A year from now, folks. All right? We have a little bit to go. The actual rise is not even to the shoelaces on his shoes. All right? 20, we don't, well, now maybe he'll be right. We have 1 year to go. So let's see what happens. Next, we're going to be seeing James Hansen. James Hansen said around 2000 we're going to be getting 5 or 6 meters by the end of the century. And he makes this graph. Well, he found out pretty soon it wasn't working too well, so then he decided, I'm going to change it. And now he says, well, it's going to be exponential. And that way, he still can't be proven wrong at this stage. And yet, at the end of the century, we are going to be going in meters, over 5 meters, in the next 80 years, okay? I'm not so sure how many of you believe this. Well, Professor Murner decided he is going to take the maximum possible that is physically possible to do. And he comes up with 10 meters a year. However, he and I both agree. You notice there's a little red dot in the bottom here? Okay, if you can't see it, this shows it a little bit better with a little red arrow. That's where the sea level really, really will be, okay? And I think you can understand where it's coming from as I go on these slides. Now I'm going to look back. The end of the last ice age was around 20,000 years ago. That's when the ice started melting. The big continental glaciers, the 2 and 3 miles of ice over Norway, the same over the United States, ending in Long Island, New York, which is the rubble that the last ice sheet left behind, if you ever get to Long Island. That's why it's long. It's called a terminal moraine. But the majority of the ice melted in a 7,000-year period, right here. That's where the sea level really rose, okay? It rose almost 140 meters as these continental glaciers melted. But at the end of that 7,000-year period, things just flattened out. Here's the more recent years. And by the way, these little tick marks are measures all over the world. This is not just one ice judgment, multiple locations. And you notice here at the end here, this is where James Hansen thinks that we're going to get another 6 meters of sea level. There he goes. We're supposed to get 5 meters in 81 years, right here. How's that going to happen? It's physically impossible, as Professor Murner showed before. Here's how we really measure coastal sea level. You do tide gauges. They are tied to the bedrock. They have a float inside. New Hampshire has a very, very significant tide range, almost 2 meters in each day, okay? But you average them all out, excuse me, and you get a good reading. But tide gauges, if you average them all, there's a bias to them. Why? Because people put tide gauges where they're worried about the sea level rising. So Holland has many, many tide gauges because they see sea level rising. It's really Holland is sinking. And other places, like Norway, they have a few tide gauges. That's where you see, they think the sea level is falling. It doesn't quite work that way. Here is a diagram from Professor Murner. It shows the effect of ice on the world presses down on the asthenosphere. These areas here, this is where Holland was, or is, it's called a forebulge. When ice melts, the forebulge sinks. So you saw this graphic in his presentation. These are tectonics in the Baltic. I call these lines isotechs. They are the same tectonics at each point in these circles. So the highest is in central Norway. You go to central Norway, you see huge mountains. That's where the water and ice that used to be there disappeared, and the earth lifts up. All right? And he noticed here the zero line is right here crossing through Denmark. Holland has 170 meter minus, okay? So Holland has sunk in 20,000 years, 170 meters. So let's go one further. This is the graphic you showed. And I'm going to go here to the tide gauge at Nyborg. It's in a place called Slipshaven in Denmark. And this is on the zero isotech line. It's been zero for a long time. This is the sea level at Slipshaven. This is 100 years now, over 100 years. You see that the rise is linear in the same direction. It varies within the 95% confidence bars, but it is linear. And again, 1.1 or so millimeters per year, consistent for 100 years. I want you to also notice that after 1991, 92, there's really no big change in direction. And that's important for stuff we'll talk about later. There's no acceleration, recent acceleration in sea level rise. And again, this is tectonically inert. It doesn't move up, doesn't move down, 1.1 millimeter, okay? Remember the 1.1 number. We heard it already from Professor Mörner. So, but do I trust Professor Mörner? No. We need to validate and verify what he does, okay? I like the guy, he's a nice guy, all right? But I have to make sure. So this is a sign that you see if you make a presentation at NASA. In God we trust, but everybody else bring data. You have to measure, calibrate, and validate. I want to make sure he did it right. So how do we do that? We go to a place where we have a GPS coupled with a tide gauge. But you want a long-term GPS. We haven't had it too much, but you have to have a GPS that's at least 10 years old. This one happens to be at Newlyn, England. It's near Cornwall. This is the datum for the entire British Isles. This tide gauge links to all the other British tide gauges. It is the one that's been there for over 100 years. So Newlyn has a subsidence of 0.7 millimeters. So what you do, the rate of change is 1.8, your net rise, 1.1. But this is now validated by GPS too. So it's not just the tide gauge. It's not also on the zero line, if you remember. All right, because here is actual subsidence going on. Well, how about the rest of the world? Here on the west coast, we have Alaska. It's the same situation as Norway. You had the weight of glaciers, and in Alaska, they think sea level is falling. All right? It's not. The west coast United States, you have the subduction of the Pacific plate, and that's pulling down the west coast. So Alaska is rising, and they think sea level is falling. The west coast is falling, I think sea level is rising. Right in the middle, at the arrow, you have, again, the isotech of zero. This one happens to be in Canada. There's a GPS station, what it looks like. And this is Prince Rupert in British Columbia. There you have, it's almost perfect isotech, 0.07 millimeters a year sea level rise, and a net rise, guess what? 1.1. Same, verified and validated. We know in tectonically inert areas, sea level is about 1.1 millimeters a year. That's it. All over the world, where you have good validation. And again, notice in the latest part, after 1993, no change in direction. All right? Now, all over the world, sea level gauges are linear. Some going down, some going up, but they are linear, straight line. Well, what about other places? Take a look at, here's a place. Here the graphic shows sea level accelerating. No, not really. Seward had an earthquake. In the earthquake, Seward, Alaska, dropped, pew, fast, 64. But the trend in sea level hasn't changed. The trend was going slightly down before the earthquake. The trend is still going slightly down. So the graphic here, which shows a rise, is absolutely incorrect. This is a bad trend line. Don't follow it. What you need to do is look at the trend lines that are before and after. That's the real trend in Seward, Alaska, even though they had a massive earthquake. So this is the real trend. I just took the second section, this section here, and you see the real trend is a falling of sea level of around 2.6 millimeters. Why? Because Alaska is rising. They think sea level is falling. Now, how about the satellites? The satellites use radars. The old version, there's 3 different satellites here. There's Topex, Poseidon, and Jason. They're all pretty linear. They are linear, notice, okay? This is a different graphic. It adds a couple of others. And they're actually quite accurate in the fact that they show a decline in 2010, 2011, where there was a huge typhoons coming up on Australia, sucking water out of the oceans, leaving it on Australia, and it basically replenished the Australian aquifer. It didn't fall on the land and go back in the ocean. So you had a sea level drop that was recorded all over the world. So we know the satellites are accurate, at least accurate in the amount of sea level that they are showing. But let me enlarge the second one first a little bit. The ENVISAT one is wrong here, and maybe I'll talk about ENVISAT a little bit later. Again, linear rise, accurate. Now the people who are doing this is Dr. Narim at the University of Colorado. These aren't people who are trying to fool anybody. They're not trying to cheat. They really believe that sea level, as found by the satellites, are rising about 3 times what the tide gauges show. Now, how come? What's going on here? First of all, they use 2 radars. They use a C-band and a KU band. Let me talk about global isostatic adjustment. This has been discussed. I'm going to get back to the radars in a minute. The theory here is that when you have a large ice sheet on, let's say, Greenland or Antarctica, the gravitational attraction of that large ice sheet pulls the ocean toward the ice and lowers sea level everywhere else, see? And when the ice melts, the sea level drops near here and rises everywhere else. It's a very, very subtle. And this is the adjustment that they try to put in the sea level numbers from the satellites. What they fail to realize, but accurately show in these diagrams, is that the massive ice on the land, when it enters the ocean, when it melts and enters the ocean, the weight of that ice pushes down on the seabed floor. And you notice a diagram here shows empty. The fact is this space gets filled with water, folks. It doesn't stay empty, all right? The ocean floor is pressed down, and the second actually shows what happens. Here you see the seabed being depressed, and you notice here the sea level actually drops. So the GIA actually needs to be subtracted from the sea level that's reported by the satellites. Now, what are the satellites doing? They're using radars that don't have good resolution. 20 centimeters, 58 centimeters. You're trying to measure millimeters. How do you do that? Well, you don't know how to do that. There's a technique in statistics. If you measure the same thing and you have a large ruler, a meter stick, that only has one end and the other end, and a small thing you're measuring, how do you find out how big it is? Well, you measure it 6,000 or 7,000 times and average them all together, and sooner or later you get to where you need to be. but it doesn't work for the satellites. The reason it doesn't work is that the satellites never measure the same ocean. They fly around the world. They are over 170 miles different each orbit. And the sea level in the oceans change. A low pressure system makes the ocean rise. A high pressure system depresses it. So you're not measuring the same thing, and if you don't measure the same thing, you can't get an accurate reading. So what are these poor people left to do? And here are these scientists, again, they're trying to do the best with radars that don't work that well. So they probably said, hey, let's add the two radars together and average them. And maybe we'll get a better reading. And that's what they did. And I believe the code that was used to do the averaging, these codes, the computer programs, have subroutines written in different languages. And when you have that, there is something called compiler clashing. Compiler clashing is when you have a high-level language like Fortran or C++. They don't give instructions to the computer. They use what's called a compiler. And what the compilers do is they allocate memory, and they make sure there's enough memory to do the calculations. And if you have different compilers, they clash sometimes, and they overwrite memory locations, which is why the code is, you have to look at the code and find out how they do it. I personally believe what happened is that they said we're going to average these readings. They added them together, and somehow the memory register that had the 2 that you have to divide it by goes overwritten. What you're getting from the satellites is a double reading of what the real sea level is, even though it's averaged. You take away and here's the easiest equation you're going to see, by the way, all day long here. You see some interesting mathematics before. This one's really simple. The latest sea level rise estimate was 2.9 millimeters. If you actually doubled the radar and didn't divide by 2, you should have gotten 1.45, knock out the GIA, and you get, look at this, 1.15. Hey, not bad, huh? For the satellite work. And yet the people who did it, they found what they were looking for and didn't look any further. This is the most important slide you're going to see, all right? Science is not complete when you are happily achieving the results you were expecting, all right? You have to dig deeper. You have to measure, calibrate, verify, and validate the numbers. And they didn't do it with the satellites. They were looking for a higher rate. They got it. They didn't realize, and by the way, there are different ways you can do an averaging. You can take a whole bunch of numbers and add them together, all right? Multiply by 5. Basically, computers can add. They don't multiply. They just add. You take your series, add them together, multiply by 5, and move your decimal point over 1. That's how you can average, where you don't need to have the number 2 in a register to divide by. They didn't do that. It's a much simpler way. Try it out at home. It works. So they didn't verify, they didn't validate it, so we have a problem. All right, so my suggestion as a mandatory public policy is to make sure that you do not use sea level rise in any public policy until the 95% confidence zone is pierced 10 years in a row. This happens to be a subset of Boston sea level rise. And Boston sea level rise bounces up and down, still linear. By the way, the green line is CO2. So you can see the effect that CO2 has on sea level, right? Once you pierce it 10 times, then you can maybe make public policy based on it. So I'm proposing for NASA that we use data transparency. Now, there are sometimes national security reasons for not revealing computer code. I can understand that, all right? But if you don't have that, I want the raw data. I want to have the program code so we can verify it, release to the public, and doing it before you make public reporting. That has never happened. So the same thing with the IPCC. If they have a model, I want to see the code. I want to see how they figure it, why they figure it. So I made a personal formal request to Administrator Bridenstine, the new administrator of NASA, that we don't make NASA funds available to anyone who is reporting NASA data on sea level and climate unless it is released to the public and open for comment. I got lucky. On the 19th of October, Administrator Bridenstine said, look, if I start engaging in what to do about science that we receive, then it makes NASA political, all right? And we don't want to do that. And the underlined part is the part I'm underlining, but he said it, okay? He's going to make sure that all the data and all of that science is made available to the public. Hasn't happened yet, but he wants to do it. And if you want to give Administrator Bridenstine some applause, please do it now. I'll make sure he hears this applause too. All right. What should you really be concerned? And we're going to get more of this later on. Take a look at the sun over the last 3 cycles. We have a declining number of sunspots, 1, 2, going down lower. Notice here around 2016, we shouldn't be hitting the 0 line at 2016. But guess what? In 2016, we already had days without sunspots. If I go back here again, they shouldn't be there. In 2017, every month had days without sunspots. Every month, no exceptions. So we're losing some solar activity. And in the same time, we measure cosmic rays, and cosmic rays go down here and up here. And I'm going to match the cosmic ray graphic to the solar graphic. All right, so here you see I stretched out the solar graphic so that the dates will line up. And you notice cosmic rays are inverse to sun activity. The more activity, less cosmic rays. The sunspot activity shields the Earth from cosmic rays. When you have a decline, cosmic rays go up. But here you have 2 trends. Not only is the sun going down, cosmic rays are going up. When cosmic rays go up, you have ionization of particles in the air that allow water vapor to condense upon them. That creates clouds. This is the equatorial Pacific. When you have clouds over the equatorial Pacific, sunlight hitting those clouds bounces off at wavelengths that CO2 does not intercept. It has to cool off the oceans. I think you're going to be hearing more of that from Professor Svensmark and Professor Shaviv in the next day or so. So I'm going to end my talk here and let you know that is there a cause and effect of CO2 and sea level rise? None that is verified. I didn't see any. They are uncorrelated. Every sea level graphic you saw had CO2 going up and linear on sea level. So I will leave you there, and we'll have some questions after Maria gives her questions. But if you're desperate, I can answer a question. But good. Thank you.